How will North Dakota continue to produce affordable, dependable electricity, keep high-paying jobs, and protect the environment into the future? Carbon capture and storage could be part of the answer.
Our mission is to safely provide low-cost energy that supports our region's economy while protecting our state's land, air, and water. We believe in sustainable energy solutions. And so we think that it is possible to have a zero-emission use of coal. And so carbon capture and storage is a big part of achieving that vision. Secondarily, we have a society that's asking for us to reduce the emissions of CO2 into the atmosphere. And so we want to lead where society wants to go. And then finally, we believe it will secure a long-term future for our coal business.
We've got the responsibility to provide power 24/7, so we've got to deal with realities that we've got now. We are probably headed for a carbon-constrained future. We've got members saying, if you can find a cleaner way to produce energy, we want you to do that. So we think it's a good idea to be investigating carbon capture and storage, both regulatory and society-wise.
In North Dakota, research is underway to investigate carbon capture and storage, to make coal part of North Dakota's clean energy future.
Carbon capture and storage is capturing the CO2 before it is emitted to the atmosphere. It's compressed and put into a pipeline where it can be transported to a location where it will be injected deep below the surface of the earth, below 3,000 feet down, to permanently store the CO2.
Oil field operators have been safely injecting CO2 for nearly 50 years. This technique, called enhanced oil recovery or EOR, also traps the CO2 deep underground. The right geology is critical to safe, permanent CO2 storage.
The geology that we're looking for is really a rock that's going to be porous, ideally a sandstone, and that's known as your injection zone. And in order to ensure that the CO2 stays in that rock formation, there needs to be overlying and underlying shales or impermeable rock to make sure that that CO2 is trapped in place. The underground injection zone not only has the space in the rock, but it has the permeability for the CO2 to travel through the rock. And so the CO2 will plume out into the geology and the formation, and so it will occupy pore space out from the wellbore. The CO2 actually becomes a solid rock over a long period of time, and then there's also a chemical reaction where the CO2 is dissolved into the formation fluid.
North Dakota is an ideal location for carbon capture and storage because we have a lot of coal-fired power plants, ethanol facilities, and other industrial sources that could take benefit of capturing CO2, in addition to having an ideal geology where CO2 storage could be handled in a safe and environmentally friendly way.
North Dakota's Williston Basin has the right combination of rocks to permanently store large quantities of CO2 deep underground. Thick layers of shale seal the CO2 storage zones and protect the fresh water near the surface. The structure of the Williston Basin makes injection safe too. One of these sandstone layers is already storing salt water from oil production.
Currently, we have over 500 wells injecting fluid into the subsurface, and they're not stimulating any earthquakes or microseismic events that are felt. So it's an exceedingly safe location to inject CO2 in the state of North Dakota.
Unlike North Dakota, other parts of the country have experienced minor seismic events associated with injecting salt water from oil and gas production.
North Dakota is in a very geologically stable area of the United States. North Dakota is also an ideal location to do carbon capture and storage from a regulatory and policy perspective.
The federal government has granted North Dakota the permission to oversee the permitting of CO2 storage within the state. The North Dakota regulatory bodies know a great deal about the subsurface, and that knowledge allows them to more effectively ensure the safety of the environment and make sure that the process of permitting can efficiently move forward.
North Dakota has been a leader in regulatory frameworks in the country for carbon capture and storage. This began back in 2009 when our legislature enacted the carbon dioxide storage statute, And our legislature also gave that pore space to the surface owner, which is important to the industry as they go ahead and develop projects. When we've received primary regulatory authority from the EPA, we became the first state in the nation to have a complete and comprehensive regulatory framework in place to move forward with overseeing the life of a CO2 storage project from start to finish.
People might have concerns with geologic CO2 storage with respect to if it's safe or not. If it will interact with their drinking water and affect the quality of their drinking water, or interact and affect the quality of their farmland or home.
Those are valid concerns, and those are all addressed through the permitting process and through our regulatory frameworks that are in place.
One of the key parts of a geologic monitoring program for CO2 storage is CO2 composition in the soil gas. We also monitor the groundwater to ensure that there is no change to the quality of the groundwater over time through the process of injecting CO2.
We look at all the wells that penetrate that injection zone and make sure that the CO2 doesn't find a leakage pathway that way.
We inject CO2 into the subsurface at a pressure in which it will not break down the formation rock. We're monitoring pressure and injection rates at the injection well. We'll also do geophysical techniques that give us a picture of where the CO2 is in the subsurface. And we also do geologic modeling and simulation to then predict out where it will go.
We have the geology with the Williston Basin, which is suitable to store large quantities of carbon dioxide. We have our oil and gas industry, which the carbon dioxide can be used to enhance oil recovery. We have the policy in place with what we've done in North Dakota to make sure that we have a regulatory certainty for industries to develop CO2 storage projects. And then in addition to that, we have the research side.
We want to continue to develop North Dakota's resources, want to continue to use the infrastructure that's in place, maintaining that way of life, those jobs, the schools, the very fine communities, and to do so in a low carbon fashion, we need to embrace carbon capture and storage technologies.
My vision is that we are able to use coal with zero emissions. What I see happening is an opportunity for us in North Dakota, first of all, to lead and capture carbon, and then secondly, store it or use it for a beneficial use. And so I think these carbon capture solutions are the future of the industry in North Dakota and quite frankly around the world.